right, what we need to do for each of these statements, we need to compare these expressions. And in this blank, we either need to put an always, a sometimes, or a never. So why don't we pause this video and have a go at that before we do it together. Okay, now let's look at this first one. So 7x minus 4x plus 5, how does that compare to 3x plus 5? Well, my impulse is, let me try to simplify what I have here on the left. So if I add, or if I take 7x and I subtract 4x's from that, I'm going to be left with 3x. So this is going to become 3x plus 5. Well, for any x, 3x plus 5 is always equal to 3x plus 5. They're the same thing. So I'll write always right over there. All right, let's do this next one. 9y minus 3y plus 4, and we have all this business on the right. Well, let's simplify both of these. If I combine 9y and this negative 3y, I get 6y, and then I still have that plus 4 there. Here, if I have 6y minus 2y, I have a 4y, and I'm going to have plus 12. So these aren't identical expressions. These are different. So it's definitely not always. But could there be some time where these are going to be the same? Maybe for a particular y value. And I'd argue yes. In fact, you could solve for that y value. You could set them equal to each other and figure out when they are the same. So let me do that, actually. You don't have to do that, but just to prove to you, 6y plus 4 is equal to 4y plus 12. Well, if you subtract 4y, let me actually, well, it's going to get a little messy, but let me just do it. If I subtract 4y from both sides, what am I going to have? I'm going to get 2y, 6y minus 4y is 2y, plus 4. I know that's hard to see. Let me write it over here. 2y plus 4 is equal to, and then I'm going to have, these are going to cancel out, and I'm just going to be left with a 12. And then if I subtract 4 from both sides, this is still messy. I should have probably done it someplace else. I'm going to get, these cancel out. I'm going to be left with 2y on the left, and that's going to be equal to 8. And then if you divide both sides by 2, you would get y is equal to 8 over 2, which is equal to 4. So there definitely is a time where these two expressions can be equal to each other. That's when y is equal to 4. So, but it's not for any y, only for y equals 4. So I would write sometimes. Sometimes. Last but not least, these two over here. Well, let's see. Once again, I'm going to simplify this. So 6y minus y is 5y, and I have 5y plus 8, and then here I have 5y minus 8. So could I have something plus 8 ever be equal to that same something minus 8? No, it doesn't matter what y is, and I could actually even try to solve it. I could say 5y plus 8 is equal to 5y minus 8. If you subtract 5y from both sides, which is a legitimate thing to do, I'm going to get 8 is equal to negative 8, which is impossible. There's no y value that can make that true. So this is definitely a never. But just reason through it. There's no scenario where whatever this is, if I add 8, it could be equal to whatever that same thing is minus 8.